January 24th, and this is your daily brief in science. Here's everything you need to know. NASA scientists have achieved a significant milestone by opening a container with the largest sample from asteroid Bennu. The contents reveal small stones and dust particles, some reaching up to 1 centimeter, all rich in carbon and water. These materials offer a window into the solar system's origins, dating back over 4.5 billion years. Surpassing expectations, NASA has secured 2.48 ounces of this extraterrestrial substance. The final tally of the gathered sample will be known in the upcoming weeks. Both the Smithsonian Institution and the University of Arizona will safeguard portions for future research. The canister's unveiling was made possible through the use of innovative non-magnetic stainless steel instruments. The discovery of water and carbon hints at the presence of organic compounds necessary for life. Scientists globally will soon receive samples for detailed examination. Meanwhile, NASA's OSIRIS-REx spacecraft sets its sights on its next target, asteroid Apophis, as the scientific community eagerly awaits a comprehensive catalog of the Bennu samples later this year. A breakthrough in visual technology has emerged from a collaboration between the University of Sussex and George Mason University, where researchers have developed a new camera system that closely replicates the colors animals see in their environments. This advanced system utilizes dual cameras and captures video across 4 color channels, boasting an impressive 92 to 99% accuracy rate when compared to traditional methods. Notably, the software code behind this innovation is open source, paving the way for continued enhancements by the wider scientific community. The implications of this technology are significant, with the potential to record animal displays in their full dynamism and vibrancy. Filmmakers stand to benefit as well, as they can now produce more accurate visual representations of how animals perceive the world. The practical applications of this system have already yielded surprising results, such as new understandings of color shifts in peacock feathers and the UV reflective properties of caterpillar defense mechanisms. These discoveries are shedding light on the intricacies of animal vision and behavior, offering a richer perspective on the natural world. Looking ahead, the researchers have plans to deploy this system in a variety of contexts, from enhancing natural history documentation to bolstering conservation efforts. This technological advancement marks a significant stride in our ability to see the world through the eyes of other species. A medical diagnostics company, ALZ-Path, has developed a new blood test named ALZ-Path p-tau217, designed to detect Alzheimer's disease. This test targets the p-tau217 protein, a known marker for the brain changes associated with Alzheimer's, and boasts an impressive accuracy rate. It has demonstrated up to 96% accuracy in pinpointing elevated levels of beta amyloid and up to 97% accuracy in identifying the tau protein. The ALZ-Path p-tau217 test represents a potential game-changer in Alzheimer's diagnosis, offering a less invasive and quicker alternative to traditional methods like lumbar punctures or PET scans. Notably, this test has the potential to diagnose Alzheimer's before the onset of symptoms, paving the way for earlier interventions and treatments. Currently, the test is only accessible for research purposes, but plans are underway to make it commercially available for clinical use, with a price range estimated between $200 and $500. The Blood Biomarker Challenge is also underway, aiming to pilot the adoption of new blood tests for Alzheimer's diagnosis. However, it's crucial to understand that the presence of biomarkers indicated by the test does not guarantee the development of Alzheimer's in every individual, and the test does not exclude other potential causes of cognitive decline. The LISTEN study is making strides in the fight against long COVID and ME/CFS, uncovering critical insights into the conditions. Researchers have identified microclots and malformed blood cells in patients with post-COVID-19 syndrome, which are believed to interfere with organ blood supply. The study also sheds light on cardiovascular disturbances and abnormalities that PCS patients experience. In parallel, a prospective study is delving into the mental health impact of long COVID, specifically examining the onset of suicidal ideation in patients. The research suggests that autonomic dysfunction and vascular irregularities may play a role in the development of ME/CFS and PCS symptoms. Moreover, a separate study published in Science points to changes in the immune system, particularly an overactive complement system, as a potential culprit behind long COVID symptoms. This hyperactivation could lead to inflammation and the formation of microclots, inflicting damage on organs. These groundbreaking findings are paving the way for new diagnostic tests and treatments for long COVID. As the research community continues to unravel the mysteries of these conditions, there is a strong call for the establishment of national guidelines and specialist clinics to provide better care for patients suffering from long COVID and ME/CFS. The collective efforts of these studies are providing hope and direction for improved patient outcomes in the future. An 11-year-old boy named Aissam Dam, born deaf, has experienced a life-changing event as the first person in the U.S. to receive gene therapy for congenital deafness. The treatment, a collaboration between Eli Lilly and Akouos, involved replacing his non-functional otoferlin gene with a working version. This intervention led to a significant improvement in Aissam's hearing, with his treated ear approaching normal auditory function. The therapy used, known as AKOTOF, didn't just benefit Aissam, it has also restored hearing for another child within a mere 30 days. Recognizing its potential, the FDA has granted AKOTOF an orphan drug designation. Looking ahead, the gene therapy trial is poised to expand to 6 centers nationwide, which could pave the way for addressing other forms of congenital deafness. In parallel, the Children's Hospital of Philadelphia has reported successes in experimental gene therapy for hereditary hearing loss. These breakthroughs underscore the rapid progress being made in gene and cell therapy, particularly for genetic mutations leading to hearing loss. The full results of this groundbreaking study are slated for presentation in February. With an estimated 200,000 individuals globally affected by otoferlin gene mutations, these advances could herald a new era in medical treatment for hearing impairment. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates at www.brief.news. For more daily podcasts about the topics you love, visit www.brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.